Okay, we're going to start with the unit circle today. So I'm going to do a quick review of 30, 60, 90, and 45, 45, 90 triangles. Those are special ratios from geometry. So if you remember what those are, you can kind of skip a little bit ahead, but it'd be good to just get a little bit of review of this. Opposite your 30 side, we called it last year, X. And then the hypotenuse is always double the side opposite the 30. Then the side opposite the 60 was always whatever the side opposite the 30 was times radical 3. So just a quick little example. If this was 5, this would be 10, and this would be 5 radical 3. If this were 30, and this were 60. Okay, now what we're going to use this for is I'm going to give you a hypotenuse, and you're going to go find the side opposite the 30, which would be divide by 2, or times by a half, divide by 2. And then whatever you get there, you're going to times that by radical 3. Right? So that's kind of what we're going to go with. If you wanted to go the other way, you would divide by radical 3. So if I gave you a side that was 6 and this was the 60, you would take the 6, divide it by radical 3, and then you would rationalize the denominator, which some of you have probably seen. That means you multiply the top and the bottom by radical 3, kind of like we did with conjugates when we had I on the bottom of a fraction. 6 radical 3 over 3, and you would get this side as 2 radical 3. That's a little review of 30, 60, 90. 45, 45, 90 is very similar. This is x, and this would be x radical 2. So similar, except it's isosceles, so both sides are equal. So if I have whatever I have here, I multiply it by radical 2. Whenever I have here, I multiply it by radical 2. Going backwards, I would be dividing by radical 2. So, brief review there, and just a reminder, sine of your angle, which we called theta from last year, it was SOHCAHTOA, opposite over hypotenuse. Cosine was SOHCAHTOA, adjacent over hypotenuse. And tangent, SOHCAHTOA, was opposite over adjacent. So, starting with the idea of the unit circle, you have a little classwork on this. The unit circle is saying, let's say we have a coordinate plane. Okay, here's my coordinate plane, centered, and I have a circle on that coordinate plane, nice and centered. Okay, I'm calling it the unit circle, meaning the radius is 1. Now what I'm going to do is I'm going to take this circle and I'm going to draw a bunch of stuff on it and then kind of erase it a lot so that you can see what I'm doing, and then kind of have a half image of what this means. Then we'll do a couple examples. If I were to tell you label 4 equidistant points, you have 1, 2, 3, 4. The radius is 1. This is 1, 0. And this is negative 1, 0. And this is 0, negative 1. And this is 0, 1. And so you have a circle with radius 1, and those are like the 4 obvious points. If I were to tell you, and I'm going to do this in quadrant 1, pick a point in the middle of quadrant 1. I would say, well, I guess right there. What would be this angle? Well, if it's quadrant 1, that's a right angle. And now if I'm going like this is 45 degrees. What is the length of my hypotenuse? That's 1. It's a circle with radius 1, so that's definitely 1. If I were to tell you to find my x, y, what is that? That would be like, well, I got to find how much over I go, and then I got to find out how much up I go. And a lot of students say like, oh, it's half, a half. Not necessarily. This isn't exactly half. It's like a little more than a half. And is this exactly 1/2 up? Look at it. It's kind of higher up. How do I do that? Well, if this is 45, this is a right angle. This is also 45 degrees. Let's do our 45, 45, 90 ratio. My hypotenuse is 1. So to find the leg, I'd have to divide by radical 2. So I'm taking that 1, and to find the x value, I'm going to divide by radical 2. I'm going to rationalize because the SAT usually has everything rationalized, and I get radical 2 over 2. So there's my answer for what my x value is. And I'd have the same as my y value. So that means that ordered pair would be radical 2 comma 2, radical 2 over 2 comma radical 2 over 2. And what this is giving us is values for important trig functions. This is giving us values for important trig functions. So when I ask you about 45 degrees for like sine or cosine, these are your answers. Let's do another one. So I'm going to erase this guy. If you can fit it in the same, in the same picture, you can. I'm just going to kind of do it. Let's say I split it into two more. They did this on the whiteboards. Let's say I split it into two more, equidistant parts. Well, I'd say, well, one's in the middle up here and one's in the middle down here. If this is 90 degrees, I have a 30, right? Because this was 45 degrees, so now that's 30. And then this is 60, right? And then that's 45. We're splitting it into like the things that we know. If this is 30, same idea. What is this xy? If that's 60, here's my right angle. Okay, here's my right angle. The hypotenuse is still 1. How do I find my x? How do I find my y? Well, my x is equal to, well, the 30 is actually easier to find. The side opposite the 30 is either. It is going from the side opposite 30 to the x. I'm going to divide by 2. So 1 divided by 2, that's a half. That's nice. And then what is my x side? That's the side opposite the 60. And we know that as whatever this is times radical 3. So 1/2 times radical 3, and we call that radical 3 over 2. Okay, so when I'm finding my trig stuff, what I'm doing is using my memorized 30, 60, 90 triangles. Oops, I erased a little too much over here. Okay, here's my 60. Again, hypotenuse is 1. There is my 60-degree angle. The side opposite the 30, which the 30 is now right here. So that means this is a half. That's my x. And then the side opposite the 60 is 1/2 times radical 3, which is my answer right there. Now you see I just have really the same values here and here because 30 and 60 go together. And then these two are the same because it's 45. That's quadrant 1 of the unit circle. I'm not going to go through how to find the rest of them. We'll kind of pick back up with that next time. But if I go over here and I say you're going to 120 degrees, meaning this is 90 and I'm going a little bit more. Right, that's 120 degrees. That's 120. This is my hypotenuse, still 1. And you're like, all right, well, how do I find that angle now? That angle doesn't really make any sense to me, like 120. I don't know anything special about 120, but if I'm saying, what is this ordered pair? I would say, well, x comma y. And you would say, oh, wait a second, if that's 120, how much is this from here, this line, the 120 line to here? Well, that is 180. So that means this is 60 degrees. Which kind of makes sense. 120 and 60 gives me 180. Makes sense. Oh, if that's 60, that means this is my radical 3 over 2 side. That means this is 30, which means at the bottom, my x is equal to 1/2, except it's going to the left on the coordinate plane, so it's negative. I'm going left by 1/2 and up by radical 3 over 2, so negative 1/2 radical 3 over 2. And you see, that's the same as this, just negative. The next point would be 45 degrees, or 135, which would be the same as this, except the x value would be negative. this would be my 150 degrees. So then the leftover is 30. And then I'd have radical 3 over 2 negative, comma, a half. So the unit circle is just a repeated pattern of the same numbers. It's a cycle. When we graph sine, it goes like this, because it's a cycle, it repeats, it's cyclic. This is a cycle, circle, cyclic. Okay, so those are the things that we have so far. I'm just going to write things that we need to know, and we're going to make sure to review these next time. The things we need to know is first, obviously, your special right triangles ratios in reference where my radius is usually 1. Radius is my hypotenuse, which is 1. And that's what your assignment is based on. We also want to know, so just kind of reminder, if I were to say what is, looking at this triangle, what is cosine of this 60-degree angle? Well, cosine is adjacent over hypotenuse, so my adjacent is negative 1/2 over hypotenuse. Oh, so it's just negative 1/2, because anything over 1 is itself. What if I ask you what's sine of 60 over here? Well, that would be radical 3 over 2 over 1. Oh, so it's just radical 3 over 2. Very nice. That basically, because our hypotenuse is 1, our x comma y values here are our cosine comma sine. Cosine is the x, sine is the y, because it is adjacent and opposite, and that's my hypotenuse. And because my hypotenuse is 1, that I can just kind of get the value right from there. Really nice. Okay, 2 things. Tangent we don't ever talk about. Tangent is not in this list. There's 2 things listed here. How do I find tangent? Well, little side note thing. If sine is opposite over hypotenuse, and if cosine is adjacent over hypotenuse, if I were to divide those 2 fractions, that's the same as multiplying by the reciprocal. I get the hypotenuses to cancel out, and I get opposite over adjacent, which is tangent. And that's just showing you that tangent is not a 12 basic function, because it is just sine divided by cosine. It's just the division. So when I ask you to find what tangent is, you would take these 2 values and divide them, making sure sine is on top. So this is what trips people up a little bit. X comma y, cosine comma sine, but then tangent is sine over cosine. So just make sure we're not mixing those up. Okay, I'm going to do a couple examples. I'm going to try to do them as quick as I can, but to show you how, like, what my logic is. It's kind of easy to break it down by examples. So I'm going to do a couple examples here. First one, let's do something basic. Let's do sine of 60. Okay, so on a quiz, I would ask you, evaluate. Sine of 60, no calculator. There's more than one answer. Well, for here, there's only one answer, but eventually we'll see that there's this cyclic pattern, so your calculator can't really help you too much sometimes. Sine of 60, first thing I say is, what quadrant is that in? Well, that's in quadrant 1, so I draw the triangle in quadrant 1. My hypotenuse is 1. I said this was 60, which means this is my 30-degree angle. Opposite that is half of 1, so a half. That side, my opposite 60 side, is 1/2 times radical 3. So that means this point would be 1/2 comma radical 3 over 2. And this is x comma y, cosine comma sine. My answer would be radical 3 over 2 is my answer. Okay, I did that a little fast. We can always slow down the video. If I were to ask you the same question, cosine of 60, I'd have the exact same picture, the exact same everything, except I'd say it's cosine comma sine. So cosine of 60 is 1/2. Okay, I'm going to do one in the second quadrant now. Let's say it's cosine of 150. So now I'm working in quadrant 2, because this is 180. My x-axis is 180. if that's 150 all the way to here, that means this little angle, which I call the reference angle, it's like a reference table. It's what I use to know what I'm doing. It's got to be 30. 150, 30 more gets me here. Okay, cool. That means this is a half because this is 1, which means down here is radical 3 over 2, except I'm negative because I'm going to the left. Radical 3 over 2, and I'm going up by a half. This point would be negative radical 3 over 2, comma, a half. And now, cosine, comma, sine, x, comma, y, my answer is my x value, my negative radical 3 over 2. So as long as you know your 30, 60, 90, you can always find the value. Some students memorize this whole thing. I don't know if that's worth it, because once you know your 30, 60, 90, you could get it relatively quickly. Draw your little triangle, label your two sides, cosine, comma, sine, boom. Let's do a tangent, and then I'll show you just two more things, not too bad. Tangent of 30. Okay, so we're in quadrant 1 over here, 30. Right angle, that's 60 up there. Here's 1. That means this is a half. This is opposite the 60, so it's radical 3 over 2. We're all positive. We're in quadrant 1. How nice. Now, how do you find tangent? Well, this point is cosine, comma, sine, x, comma, y. But my tangent is equal to sine over cosine. X, comma, y, cosine, comma, sine. Sine is my y value. Cosine is my x value. I times by the reciprocal. My 2's go away. And then unfortunately, because it's always kind of shown like that, we're going to rationalize this. So kind of a lot of steps for this one, which is why I'm showing this one. And I get radical 3 over 3 as my answer for tangent of 30. Radical 3 over 3. So now you got radical 3 over 2. You got radical 3 over 3. There's a lot of options you have here. Okay, so that's my answer for tangent. You've seen one of each, one in the different quadrant. You have some examples to do. I'll show you two of the kind of the oddball ones, which are a little bit easier than you would think. Okay, if I were to tell you what is sine of 90, okay, well, how do I draw this? Like, what's my plan for this? I can't draw a triangle at 90. Exactly, so if I have my circle, this point up here is 0, comma 1. This point is 1, 0. This is negative 1, 0. And this is 0, negative 1. Right, so when I give you a 90 or a 180, or I give you a value of 270 or a value of 360, right? So you're on one of these quadrant lines. I call this a quadrantal. You're just using those points. You can't really make a triangle. So sine of 90 is, okay, so that means I'm somewhere up here. Reminder, cosine, comma, sine. Cosine, comma, sine. So sine of 90 is 1. Let's say we're to give you cosine of, let's go to 70. That puts me 90, 180, 270. I'm down here. Cosine, comma, sine, that is 0. I'll do one for tangent. Tangent of 180. Right here. Oh, cosine, comma, sine. But I'm looking for tangent, so it's 0 divided by negative 1, which is 0. But if I were to tell you what is tangent of 90, that would be, that's that top one. I'll write it up here. Tangent of 90 would be sine over cosine 1 over 0, and that is undefined. So you could get an answer of undefined. okay? Now you'll eventually have a quiz where I'll kind of ask you any version of this. I could ask you stuff in quadrant 1, 2, 3, or 4. Okay. On your classwork, you have a couple things in this different unit of measure called radians. I'll do this quick. I'm hoping this video isn't too long. Radians is a different unit. Radians, these are both units for angle measure. Units for angle measure. So most things we know are in degrees, like 30 degrees. I can convert that to radians by multiplying by pi divided by 180. And I'll talk more about why later. And then when I do that, I'm converting it to a unit that's the same as the output. Right? If you think about this, 150 degrees and a radical 3/2, like feet, don't really make sense. It's like plugging in fluid ounces and getting out kilograms. It doesn't really make, like, they're not the same unit. So same idea here. I want the input and the output to be the same unit. I can simplify this and get pi over 6. So that is my radian amount for 30 degrees. Those are equivalent. On your classwork, you have some things in different angles. Let's just pick one. I think I did one. Let's go 5 pi over 3, I think is one I did. To convert from radians to degrees, you would do the opposite, times it by 180 over pi. Kind of like what we've been seeing, where when you divide by something, it's the same as multiplying by the reciprocal. My pi's cancel. My 3 and my 180 give me a 60, and I get 300 degrees. Okay, let's say I get 2 pi over, or let's do 5 pi over 6. If I want to, would be my first step, is convert it into degrees, because I know what to do for degrees. That's 30. Those go away, and I get 150 pi. Right, so you can always convert it to degrees. I would do that first, and then say 150. This means I'm in quadrant 2. This means I'm in quadrant 4. So now my triangle would look like that. 300 means that this is 60. In quadrant 2, I already did a 150, right? So you're just using your 30, 60, 90 based on where it is. So you find out where it is first in degrees. That's easiest for us. And then do your 30, 60, 90. You have a couple examples to do for classwork. Good luck.